exponential decay is that it's easy, yes, and it uses all these same exact properties of what we did yesterday with exponential growth. Everything that we did yesterday doesn't change. When we go to graph them, we graph a parent function first, we shift it just like we did with the h's and k. The only thing that is different between exponential growth and exponential decay is the following. Your value of b, when you have y equals a times b to the x minus h plus k, this value of b is fractional. It's between 0 and 1. Whereas exponential growth, it wasn't. It was usually a whole number. 1, 1.5, something along those lines. Exponential decay has a fraction for b. That's the easiest way to tell the two of them apart. Okay? What happens then is that our graphs are going to go different directions. Yesterday you had exponential growth that were kind of scooping up to the right, or they had them where they had the negative value where they're going down and right like that. Well, today it's just going to be going the other direction. It's just going to be swooping downward or upward to each other. All right? And you'll see it as we go through them. Yes. I can tell. So what happens again, when we go to plot these things to start with, the tricky part lies with having to work with a fractional b value. Well, you're going to use, instead of positive exponents, you'll use negative exponents. Because what happens when you have a fraction raised to a negative exponent? It flips it, and it usually becomes an integer. So it ends up being rather nice. So let's look at an example to start with graphing. What I'm going to do here is just start with a plain, boring one. Nothing too fancy, just an A to B without the shift. And then we'll do one with the shift and go on our own merry way. I know, you never know if you need more. Graph paper is fun. All right. So again, in this case here, I have y equals 3 times 1/4 to the x. Trust me, guys, we'll get done with this real fast. Last hour it took us about 20 minutes, and I gave everybody time to get this stuff done. In this case here, again, I always start out with my a value, which is 3. My b value is 1/4. Does everybody agree that there is no shift here? When I go to graph one that has no shift, do I need to worry about doing anything with dotted lines? All right. So just like yesterday, where will my y-intercept occur? 0. Well, it's always 0, but what's the value? 3. Very good. Remember, your y-intercept will always occur at the value of a. Hairball?
Those are.
You get a hard breather. I choked to death. It's all right. Hey. So again, some people need water. It's like a hawk of loot. Oh. Plot. Anyway. Plot operator. Now, if I'm going to use positive exponents to figure out my next ordered pair, if I used 1, I'd have 3 times 1/4. I get 3/4. It's kind of a pain to work with that. If I use -1, just to kind of give you the idea of what's going on here, 1/4 to the -1 is what? Is 4. What's 3 times 4? So at -1, it's up at 12. And it's just doing this. That's fine. You can kind of fake it. Now remember, you will still have a horizontal asymptote with these guys. If there's no shift, your horizontal asymptote will be at 0. If there's a shift, it will be at where the shift is. Which shift? The horizontal or the vertical?
The horizontal.
Okay. Is it rising? All right. So again, like I said, it'll ask you about domains and ranges. Are there any parameters that you have to worry about in your domain here? So your domains for these are going to be all real numbers. Your range, remember, which side of the graph is the range is being shown? Is it above 0 or is it below 0? That's probably below 0 right now. Second semester jokes don't get any funnier. So your range would be greater than 0. Okay? Let's look at the some of the shift.
Shut up,
Same idea here. Same idea. When I go to shift, when I set these things up, I'm also going to still label out what my A, my B, A, B, H's, and K's are going to wind up working with. Excuse me. My A value, -3. B is 1/2. H, is it 2 or positive 2 or -2? Very good. And K, is it +1 or -1? +1, very good.
Sorry.
Sure.
Just texted me.
Well, it's that Clash of
Yeah.
Go ahead and shut it off then.
Oh, it's off. Actually, I'm not ready. That's okay.
You gotta give him credit, he's owning it. He's just like, oh, I'm busted. Gonna pay attention now. So just like we did yesterday, we plot the parent function. When you plot a parent function, is it solid or dotted? Okay, so I'm going to plot it at y equals -3 times 1/2 to the x. Where will my y-intercept occur?
3.
-3. Remember there's a negative there, so it's -3. And now I want to pick a value that's going to work out rather nicely. I'm going to use -1 for my x value. Again, the reason why I'm going to use a -1 is that I know this is an exponential decay problem. That -1 switches the 1/2 to becoming 2, and -3 times 2 is? So at -1, it's -6. The parent function, again, has the horizontal asymptote where? So I know that this graph is going to do this. And now the last thing I have to do is shift it. It's going to have to move left or right. How many? And up or down? How many? Good. So I move them left 2, up 1, left 2, up 1. And how far do I have to move my vertical asymptote? Up 1. And just make this one solid. And there you go. Do you see how this mirrors exactly what you did yesterday? You're just going in another direction. Not very difficult. Remember, if you forget, if you're having problems trying to decipher what values to use for your ordered pairs for choosing, you have a table function on your calculator. Nice save. Nice save. You have a table function on your calculator, you can find ordered pairs that make it work. When we're graphing these things, all you gotta do is put out 2 points and shift them. Okay? Yes, sir.
Putting in equations like that in the calculator.
Nice. Yeah.
How do you do the exponents like x plus 2?
You have, when you raise the exponent, it jumps up there. It'll let you go x plus 2, then you have to hit the right button to drop it down to the exponent.
When I do y equals, it doesn't go up. It has an arrow pointing up and then x plus 2.
Let's see here. If I do this, -3 parentheses, I'll just use 0.5 because it's easier to type. To the, doesn't yours go up like that and have a box? Really? You might have the older op system then. Okay, you'll have to put yours in parentheses. I just don't have the operating system.
Are you kidding me?
Okay, let me see if I can get a different function for but yeah, well, with this, use your parentheses for now. You had your I thought all you got done.
And now you're pressing your left side.
All right, so that's graphing. It's that easy. It's the same thing we did yesterday. The other thing we're going to talk about today is something called exponential decay.
Oh, that wasn't exponential.
No, it's called depreciation, what I'm looking at. It's the decay model. Well, this was exponential decay. But I should say exponential decay modeling. Excuse me. So if I'm looking at exponential decay modeling, I'm not looking at dead people wearing sunglasses.
I can't wait to do that.
Okay, modeling.
That's so funny.
It's not funny.
It's really not. Honestly, it's really
Did you get a pumpkin for your head? Are you like that? Are you Ichabod? Anywho, the only difference between exponential growth models and exponential decay models is the following. It's a minus sign. A is still your initial amount. R is your rate. It's a percentage as a decimal. And T is in time. It's usually years, just like it was yesterday. Instead of having a growth factor, we have now a decay factor. All right. Now, what you see the most with depreciation, the easiest thing to explain how this works and how things model is when you're talking about cars and trucks. Those are the things that depreciate the fastest and at different rates, if you will. Some cars depreciate faster than others. Other cars appreciate over time as well. Yes, sir?
Just the opposite of the exponential growth.
Yeah. Pretty much. Yeah.
What's the arrow say?
Initial amount.
No, for R.
It's the rate. It's a percentage as a rate as a decimal again. So what happens here? So we have A1 minus R to the T. A real easy example for this is to look at a new car. If you buy a new car, woohoo, for $24,000, basically the minute you drive it off the lot, it's worth a lot less. Not that much. Well, depends on the car. It'll be worth a lot less.
A lot less?
Yeah.
However, if you drove it off,
Some of the cars that depreciate the fastest are usually the most expensive. And I have a list. I'm going to show you this in a second here. If any of you guys know things about cars, you'll understand what I'm talking about with some of these things. Or things that hold their value. You know, cars that hold their value. And I've got example things like that too. What happens here is if you buy a car that's $24,000, and let's say it depreciates at an annual rate of about 16% a year. It's not a bad depreciation, to be honest with you. Your model is basically working out the same way. Your initial amount, 24 grand. It's 1 minus, well, what's 16% as a decimal? And then it's time in years. Again, like we did yesterday, I am not going to ask that you guys graph these models. It's kind of pointless because your y-intercepts are awful. But we can always look at tables. And looking at tables will allow you to figure out values rather easily. So for this example here, I want to know how much is this car worth after 2 years? What am I going to use for T? 2. So there's 2 ways to go about this. In this example, what I'm going to do is show you guys how to do this all via your calculator. So open your calculator back up here, and we have y equals 24,000, parentheses, 1 minus 0.16, close it to the... I'm going to change my value of t because I'm going to look at my table. I'm going to use my variable here, because this is what I'm looking for. I'm going to use x. Hit table. So if I want to know how much the car is worth after 2 years, that means my x value is now 2. So if I look at the table, at 2 it's worth what, 16,934? Okay. Now, if you think about it, a lot of times your car loans are, nowadays they're about 5 years on car loans. They used to be 3, 4 years, but usually people push them off about 5 years. If you have a car loan that's about 5 years and you're only paid on it for 2 years, you have not paid down the principal enough to warrant being able to trade that thing in. You ever heard the term being underwater? You probably heard that about like mortgages and things like that. Kind of the same idea. You don't have any, you ever heard the term equity? Equity, all right. For something that you own, say you bought a car, all right? Say you bought a car, it was worth $10,000. You bought it and you're paying $200 a month on it, just for a real boring example here. And in 2 years you've paid, what does that be, $2,400 off the $10,000 loan. But all of that is not included, it's just principal and interest. So if you take off the interest you're paying on that, maybe you've only paid, instead of $2,400, maybe you only paid $1,800. So right now you owe $8,200, but the car might only be worth $7,000. So if you go to trade it in, they'll give you $7,000, but you got to come with an extra check for $1,200 more to cover the cost of the car. Does that make sense?
Right.
That's what they mean by being underwater. And that's happened a lot with mortgages. When people bought their houses would appreciate in value. All of a sudden the bottom fell out. Everybody thought their house was worth $300,000, but now they can only sell it for $110,000. You're underwater by $190,000. So if you sell your house at $110,000, you would take a loss of a tremendous amount, but you still owe that money. You'd have to go to the bank and say, I sold my house, but I still owe this much money on my initial loan. That's why you're not seeing people move out of their houses. Not many houses are being sold, or they're starting to come around. It's starting to get there, but that's what this whole market, that's what happened in the market. So it happens with cars, it happens with homes, things like that. Now, you're talking about the Lamborghinis and things like that.
I just looked up a Rolls Royce. There's a 1979. It's only worth $20,000.
Oh, even that, I mean,
Ridiculous.
those of you guys don't know, I'm a car guy. I love cars, I love motorcycles, I like trucks, I like things like that. Things that have wheels that move. I've always been one of those kind of people. And one of the things that I looked up to talk about with you guys today about like depreciation, the different types of vehicles that depreciate the fastest. This was a list of you guys ever heard of Kelley Blue Book before?
Yeah.
Great tool for shopping for cars, seeing what your car's worth, things like that. It's a great tool. As you guys get older, you'll start to use this more and more. Some of the cars right now that are depreciating the fastest, which is surprising, are electric cars. Have you guys all heard about the Nissan Leaf?
Yeah, I have.
Basically, you plug one of those things in. Yes, sir.
Oh, it's because lithium-ion batteries, they really do not last.
Correct, and that's one of the main reasons. If you go out and buy a brand new Nissan Leaf, they're 35 grand-ish, somewhere in that neighborhood. And after 5 years, it's only going to be worth 18% of what you paid for it. And the reason why it loses that much value is because those batteries eventually are going to have to be replaced, and they're extremely expensive. That's why nobody's buying electric cars, because no one's come up with a good way of continuing to keep batteries from dying out. You guys all know that. Your phones don't hold charges as long as they used to when you first got them.
Right.
The battery lives die out. So other things that depreciate really fast as far as cars are concerned are very expensive cars. You know, Jaguars, the Mercedes, the BMW 7 Series, the CL classes, those are some of the real high-end cars. The 7 Series for BMWs, that's like their top-of-the-line ones. Some of those things are $110,000 for a BMW 7 Series. After 3 years, you could probably pick one up for about 40 grand. Main reasons those big ticket, expensive branded name, Mercedes, BMW, Volvo, some of those things are so expensive and they depreciate so fast. Maintenance is very expensive. Parts are very expensive. So if there's ever replacing brakes, a brake job on a Mercedes can cost you a couple grand. Yeah.
How much was 1964?
I don't know. $6.
Really?
I don't know. So things like that. Trucks. Yeah, we're a nation of people that loves trucks. I love trucks. I have a giant SUV. I've been driving those things all my life. When you look at trucks, a lot of times trucks tend to hold their value more than some cars. This is kind of a crazy analogy, but have you ever seen militias on the news? Militiamen, they're fighting. They're always guys running around in T-shirts, like it says like AK-47s. What kind of trucks are they driving? You ever look at this? Look at every single militia. Whenever you see it on TV, what kind of a truck are they driving?
Dust covered.
Old one?
Dust covered. They're driving Toyota Tacomas.
What?
Seriously, they're driving tacos.
Tacos?
They call them tacos. Seriously, every single militiaman you will always see,
Super light.
they're usually driving Toyota Tacomas. And the reason why they're driving those is because they're extremely reliable. They last forever. One of those
They're
things.
driving in that?
Yeah. Seriously, they've got an M60 mounted in the pickup truck bed. They're driving these things, beating them apart because they're going to last forever. These things are bulletproof, but their engines and the transmission, these cars are extremely well made. I kid you not. Go back and look at like footages of CNN of fighting in the Middle East, fighting in Africa, fighting all over the place, in Libya and all that. Everybody driving around is driving in a white one of those.
White.
I don't know, because it's cheap. I don't know. But they're always driving around in those things. Ask Mr. Plascota. He's a car guy.
How about tractor?
Plascota. What does every single militiaman drive?
Oh, that's a Toyota Tacoma.
See? Not even prompted. And he's a car guy. So why do the Tacomas hold their value?
Because everyone wants
Exactly.
They're lonesome?
Because they're lonesome, yes. They hold them dear themselves. Oh, Toyota Tacoma, I love you so. That's what we're doing. Because we're talking about depreciation. What things don't depreciate as fast? Why don't they depreciate? Because the militia then want them.
This is true.
Seriously, all you'll see, you're going to see.
You're looking at every one of the movies that are about like some war in a third world country.
They're
Guess what
driving a white one.
They're driving these things.
Every one of them.
You're too excited.
I want to go.
They're wearing T-shirts from the Super Bowl loser. That's when they all get shipped.
Yeah,
Seriously,
yeah, that's true.
they're all wearing those, and they have an AK-47 and a white Toyota Tacoma.
Usually the AK-47 is mounted to the roof.
It's found. Oh, it's an M60. They put in the back.
Yeah.
There's around it.
Okay, you guys know too much about this.
We're car guys.
No, you guys know about going in a car.
We're older than you. We know things about the world.
Watch the
I don't think
news.
it's the world like
Like what?
What? What? Lay it on me.
I don't know, the
those
same
third
frame.
world countries. Okay.
Located where?
It's located on the Caribbean near the Dominican Republic.
So don't touch that.
I taught myself
No, you
that. I'm not
didn't.
a complete moron. Oh, but
How
you know.
close it is to the Dominican Republic?
It's very close.
How close?
It's like on the same island.
Very good.
Oh.
Try to catch her on that one. So, like I said, depreciation stuff you guys are going to see. Thank you, Mr. Scotta. Depreciation is stuff you guys are going to see, you're going to use. It's a valuable tool to look at when you guys do eventually start shopping for new vehicles, things like that. Just keep that in mind when you're looking at things. Don't just go in on a whim saying, oh, this is awesome. I want one of
I'm
those.
gonna tweet about this.
If this thing.
Mr. Griffey makes me always about
You know what, though? You'd be surprised, not as many as, these are highly esteemed. There are certain cars that are stolen more than others. Nowadays, they're going after things that have a lot more of the chrome, some of the heavier duty parts. You see a lot more F-250s, 2500 series Chevys. You see Escalades, things like that are getting stolen more than the old Civics and Honda Accords and things like that. Just because they're looking for the high-end parts that are in there, the suspensions, the exhaust stuff. It's just, and also some of the reasons that a lot of the 2 series, like the 3/4 ton style trucks, are broken into and stolen a lot. Who are the type of people that drive 3/4 ton trucks? Besides farmers and stuff like that. What's that?
I guess people throw over
Construction work.
Construction workers. And what's inside the back of most construction workers' stuff? Tools. A lot of valuable stuff. That's why those types of trucks are stolen quite often. Okay. So, thought I'd bring in a little bit more than just boring old math, but that's all it is.
Yeah, the truck, more details.
What's that?
That's how you bring them to class.
Yeah.
No, why would
Why would you need to?
It's easier just to, if you can't get into it, not to take all of it with you. So let me give you some problems to look after tonight. Not these, do something different.
in the neighborhood.
Yeah, no homework.
Go and take the tractor another round.
Okay.
This might not work. Do these.
Are any of them graphs?
The first 4 of them are the regular shifting graphs. What I'm talking about here is 43 through 56. Just like you did yesterday, you know how they had all the different models and they asked you to graph the model? These are the ones I don't want you to graph. These 4 are graphs with shifting. So when you go to shift them again, please draw your parent function and then with the dotted and then just make a solid line with the other.
How many graphs are there?
4. All right? Once again, these 4 are regular, old, boring graphing problems. These are the modeling style. If the question in the modeling says graph it, don't. Just like I said yesterday. There's no reason that you're going to use your calculator more to do that anyway. Of these, yes. Yes, sir. What we do on Monday and Tuesday. All right.
If we don't have school, I don't want to do it either.
Then we'll push everything back however many days we need.